Okay, just looking at the last little section for this 5.3. So this is other families of polynomials. So what I've got is a set of axes, and I'm going to look at the line y equals 3x. Okay, and what similarities does that have? And um, so we look at the various sets of polynomials which share a common feature or features which may be considered as a family. Okay, so families are described as common equation which contains one or more constants that can be varied in a value. So such a varying constant is called a parameter. An example of a set of linear polynomials, each with gradient 3, but with a differing y-intercept. So here's my first one. Okay, y-intercept is 0. So a very similar one would be this equation here. Y equals 3x, and we're going to have take 1, okay, because it's going to go through the point -1. I can look at this example here too. Okay, y equals 3x, very similar, and it's going to go through the +1. And I could do the same thing for -2 and +2, and I can keep going. So what we can say is this is a family of parallel lines defined by the equation y equals 3x plus some constant c. And c is going to be part of the real numbers. And I've shown a couple of numbers here, so -1, +1. Okay, I could have done this one as well. 3x take 2 and +2. So these are all families of polynomials. In this case, they're all linear. So this set of lines is generated by allowing the parameter c to take the values -2, -1, 0, 1, 2, 3, and so on. So as could be anticipated, these values of c are the y-intercepts of each line. Okay, pretty straightforward for straight lines. Gets a little bit more complicated for when we get to polynomials, which is our next step, which is what we're going to be doing. So example 7, we're looking at y equals x cubed plus mx squared. So we're considering the family of cubic polynomials defined by the equation, and the parameter m is a non-zero constant. So m non-zero. First part, calculate the x-intercepts and express them in terms of m. So even though we've got m, it's some kind of constant and it's going to be part of the family, so it's going to change depending on what equation we want, but the calculations are the same. So x-intercept, we solve for 0. Okay, common factor of x squared in both, so take that as a factor. You have x plus m. So what are my solutions? It'll be x squared equals 0, so x equals 0, or x plus m equals 0, so x equals minus m. So they're my x-intercepts. So I'm going to have 1, and depending on what m is, will be my other x-intercept. Now, part B, draw a sketch of the shape of the curve for positive and negative values of m, and comment on the behavior of the graph. So part B, so due to the multiplicity of the factor, there is a turning point at 0, 0. So if we draw in our set of axes, right, so when I factorized this equation, so I can actually say y equals x squared x plus m. Now because I've got an x squared term, that means there's going to be a turning point. And the turning point is going to be at 0, 0, because I haven't moved it left or right. So that's where the turning point comes from. So we know there's going to be a turning point here. Now, if m is negative, we're going to have a x-intercept at positive m. But if m is positive, we'll have 1 at negative m. Okay, so I'll have a look at the if m is, we'll say positive to start with. So if m is positive, we get a negative. So this will be negative m. Okay, how did I get that? So x equals negative, and m is going to be negative. Sorry, m is going to be positive, so we get minus m. If m was negative for our original equation, so if it was x take 2, for example, we'd have negative 2 for m, which gives us a positive number. So if m is positive, our x-intercept's going to be negative. If m is negative, it's going to be positive. So we'll just have a look at this one first, if it's m's positive. Okay, our graph is a cubic, and we've got a positive cubic, so it's going to start from the bottom and go up and touches that point. Okay, so that's for m is positive, so m greater than 0. Now, if m is less than 0, or negative, we'll have a number over here at the opposite, which is positive. So this point here at the turning point doesn't change, but it's going to go through that point there. Oops. We'll say it's there. Okay, so same point goes through 0, or touches 0, 0 as the turning point. In this case it's a maximum, but over here we've got a minimum. Now, why is that a maximum? Well, we're looking at for m is negative, so y equals x squared, x take m. Okay, expand that out, you'd have x cubed take mx squared. So in this case it's going to be a negative graph, so we start from actually no, scratch that, don't worry about that, it's the same situation. So that's the two graphs. So the behavior of the graph at the origin, okay, at the origin we had a minimum for the first one, for the second one we had a maximum. Part C asks us to determine the equation of the member of the family that contains the point 749. So we're looking for what equation could be this one here that has the point 749. So what is our equation? That's what we're looking for. So what value of m does it have to be? Well, we know that y equals x cubed plus mx squared. And we know this point, so let's use it. Y is going to be 49, x is going to be 7. So just subbing those 2 points in. 7 cubed. That's a big number. And 7 squared is 49. So we got 49m, and actually what we'll say is 49 times 7. And taking 49 as a factor, we'll have 7 plus m. And we can divide by 49, so we have 1 equals 7 plus m, so m has to be equal to, if we take 7 across, minus 6. So what's our equation? It would be y equals x cubed